Welcome to section 9.6, day 3, polar coordinates. Yesterday we talked about converting points from rectangular to polar and polar to rectangular. Today we're going to look at converting equations. So to convert equations, we need to know some of those formulas that we talked about the other day that we derived, where x is equal to r cosine theta, y is equal to r sine theta. Then we have Pythagorean theorem, x squared plus y squared is equal to r squared, and tangent of theta is equal to y over x. And remember, those all came from the triangle where we set up our adjacent opposite sides and everything. So we've already derived those formulas from previous lessons. So in example 1, I want to convert the rectangular equation to polar form. So as we're looking to convert this, what are the things that we notice? Well, notice that we have an x squared plus y squared. So we're trying to see things in rectangular form so that we can convert them to polar form. All right. So how do we get the x squared plus y squared? Well, we can factor out the 3, knowing that x squared plus y squared is equal to r squared. We can also convert the y to polar form, which is r sine theta. So 3r squared is equal to r sine of theta. Now when we convert this into polar form, we either want to solve for the r or solve for the theta. So you can see on this one that we have this common r, and we have an r squared and an r, but since they're in common, if we divide by r, we get 3r is equal to sine of theta, and then we can isolate the r by dividing by 3. So we get 1/3 sine of theta. So there's an example of taking a rectangular equation and converting it to polar form. Once again, looking to solve for r or sine theta if there is no r value. Example 2, let's take a look at a couple more here. Convert from rectangular equation to polar form. So on 2a, we got 5x plus 6y minus 3 is equal to 0. So we will take the x value and convert it to polar form. So that would be r cosine of theta. And then the y value would be r sine of theta. Minus 3 is equal to 0. Now we can rewrite this as 5r cosine of theta plus 6r sine of theta minus 3 equals 0. We need to get the r by itself, so factor out the r. So that would be 5 cosine of theta plus 6 sine of theta. Now I'm going to add that 3 to the other side, because to isolate the r, we're going to have to divide by that entire quantity, 5 cosine of theta plus 6 sine of theta. So that'll give us r is equal to 3 divided by 5 cosine of theta plus 6 sine of theta. Alright, and then let's look at 2b. Y is equal to the square root of 3x. If we divide by x on this one, we will get y over x is equal to the square root of 3. Now, you might not recognize that, but knowing that the ratio y over x is equal to tangent of theta, these are things that we have to look for. So tangent of theta is equal to the square root of 3. So we can isolate the theta by answering this question is what is tangent of what angle is equal to square root of 3, and then that will be pi over 3. So theta is equal to pi over 3. Now some of you might have looked at this and said, well, I didn't look at it that way. I said y was equal to r sine of theta, and then we had the square root of 3 times x, which is r cosine of theta. Well, that's perfectly fine. You could have divided by r cosine of theta to get the r's on the same side. The r's would have canceled to leave you with sine of theta divided by cosine of theta, and knowing that you have your quotient identity, sine over cosine is equal to tangent, so tangent of theta is equal to the square root of 3, so we're still left with theta is equal to this pi over 3, sorry about that. So theta is equal to the angle pi over 3. So either way, you would get to the same end result. And remember, when you're done, you're trying to be in polar form, so you should only have r and theta as variables. You shouldn't have any x's and y's left over. Alright, now let's go ahead and look going from polar to rectangular form. There's two common techniques used. One is to multiply both sides by r, and the other one is to square both sides. So we'll kind of look at both of those techniques. On A, we have r is equal to 4. So if r is equal to 4, if we square both sides, that would give us the r squared. Remember, r squared we can rewrite as x squared plus y squared. So to convert this, we'll change that r squared to x squared plus y squared, which is equal to 16, and that will be a circle centered at 0, 0 with a radius of 4. So knowing what you're converting that to and what that's going to look like is going to be another part of what we're going to be looking at going from polar to rectangular form. So let's go ahead and look at B. R is equal to 4 sine of theta. Now on this one, this would be better to multiply both sides by r. It still gives us the r squared, but in addition to that, by multiplying by r, is we get r sine of theta, which is equivalent to the y value. So once again, practice on this stuff is going to help you know what you should be doing. So x squared plus y squared is equal to 4 times y. And so if we get x squared plus y squared and subtract the 4y, we're going to go ahead and complete the square so we can get this in the correct circle form. So x squared plus half of negative 4 is negative 2. Negative 2 squared is 4, so you add 4 to both sides. And now you can see once again it's still a circle, but this one is centered at 0, 2 with a radius of 2. Alright, now that we've used those two common techniques, let's go ahead and look at a couple more of these. Look a little different, but if you want to pause the video and give it a try, I think that'd be a good idea. So let's go ahead and get started on example 4a. We're still going to convert from polar to rectangular. Now when you look at it, you still have that r, so we know either to square both sides, but because there's a secant over there, we might want to multiply by r. But also, what about the secant? What does that represent? Well, why don't we take secant and rewrite it as 1 over cosine. So we have r equals 3 divided by cosine of theta. So before we make any decision just yet, let's go ahead and multiply both sides by cosine of theta. And so look what happens. R times cosine of theta is equal to 3. Well, r times cosine of theta represents x, so x is equal to 3. So all we're looking at here is a vertical line going through x equals 3. So before we made too many decisions there, we went ahead and simplified secant, or rewrote it using its reciprocal, and then multiplied by the denominator to get r cosine of theta to replace with x. Once again, go back to that first page where you have these 4 things or formulas that you guys are going to be using as you go through and convert these. Keep those in front of you as you guys are working through these problems. Okay, so let's go ahead and look at the last one. Theta is equal to 3 pi over 4. Theta is equal to 3 pi over 4. Well, we know tangent of theta is equal to that ratio y over x. So what if we, as long as we do it to both sides, take tangent of theta and tangent of 3 pi over 4? Well, tangent of theta can be rewritten as the ratio y divided by x, or y over x. And so now we have y over x is equal to, well, what's tangent of 3 pi over 4? That's equal to negative 1. We'll multiply both sides by x because we are trying to get this into rectangular form. We want y equals, so y would be equal to negative x. That's just an equation in slope-intercept form with a slope of negative 1 and a y-intercept of 0, 0. So there's another example of how to convert a polar equation to rectangular form. And so that is it for the day 3 of polar coordinates. We've done a lot of converting in this section alone, converting equations, but we've also in day 2 converted points. And then in day 1 we really just looked at the idea of what a polar coordinate was. So once again, write your summary down here. What are those important takeaways? I mean, the start of those 4 common formulas that we're going to be using to convert each of these, and then what are some of those techniques that we use to convert from polar to rectangular.